I'm a master in aerospace from KTH and a PhD in aerodynamics from NTNU. I worked 13 years as a researcher for Christian Michelsen Research up at Farmtoft in Bergen, in a department called Prototech. And I also worked almost 2 years for Siemens Gamesa in Denmark in the offshore rotor performance group. Currently, I'm associate professor at HVL. I'm teaching 2 courses. One is Ocean Renewable Energy. We will probably call this course Offshore Wind Energy next year. And I'm also teaching in another course called Marine Structures. And I have a picture of my glider here. On my free time, I fly glider planes. And this specific glider actually has an airfoil that it was also used on wind turbines. Not the modern ones, but the older, smaller turbines. So that's pretty fun that we can actually, the technology is very comparable. In the top picture here, this is me at the test center at Østerild in Denmark. So this is the test center for all the big wind turbine manufacturers. And as part of the job, we were allowed to, on some occasions, go and play with the 200-meter in diameter test turbine that Siemens Gamesa had situated there. Yes, so I'm going to talk a little bit about the background for the importance of why big wind turbines is a problem. We are likely to see a 2-degree warming by 2050. We have had high hopes for 1.5 degree for a long time, but it's not looking too good for that. July 2023 was 1.18 degrees. This is warmer than any month in 143 years of measuring. And 2023 is expected to be the warmest year in recorded history. So in this GIF animation of measurements from NASA, we kind of see the trend. Its temperature is increasing rapidly due to carbon dioxide in the atmosphere. And this has to be kept under control somehow. A very interesting new study published in Nature Climate Change looked into the economy of what global warming actually means. And they found that it's to limit climate change is very beneficial for the future economy, our children's economy, if you like. And the study shows that if we allow 3 degrees rise in temperature, the cost due to climate change would be in the order of 10 to 12% of GDP by the year 2100. So that's a pretty high cost for future generations to pay. However, if we manage to keep it below 2 degrees, maybe we can get away with paying about 2% of GDP to fix the scenario that comes with global warming. The articles are listed below if you want to read up on this in detail. So the European response to this is to introduce the European Green Deal. And in this commitment, the European Union will become climate neutral by 2050. So this means that we are changing to an economy with net zero greenhouse gas emissions in 27 years. So if you look at the diagrams here, what this means, these are 2019 numbers, but they are pretty equal to today. We see that we are going from something that we are reducing oil from 37 to 2%, and we are reducing natural gas from 22 to 1%. And then we are bumping up the electricity production from 25 to 57% to get the energy that we need. And this is put into law. So the European climate law ensures that the EU policies contribute to this goal. So all politicians in all EU countries should follow this by law. So this is pretty serious stuff. So hopefully EU will be successful with this initiative, but of course the rest of the world also need to follow. Otherwise, it's not helping much. And where does wind energy come into this? So to realize this, offshore wind is a key technology. They are planning 400 to 450 gigawatt of offshore wind capacity, additional wind capacity installed by 2050. And this is like about 13 or 14 times more capacity than we have today. And these are the guys that are supposed to help us do this. These are the 4 big companies in the West or in Europe. This is American, but in the West. So we have GE, Vestas, Siemens Energy, or formerly Siemens Gamesa, and Nordex. And these guys, they supply kind of 90% of the market outside China. China is really going hard into wind energy, and Goldwind and Mingyang are just everywhere now. In 2021, China built more offshore wind than the rest of the world combined for the last 5 years. So these are enormous subsidized companies coming out of China, really making offshore or wind energy mass-produced big product. So they are actually now challenging. Goldwind here is actually challenging Vestas as for the position as the largest wind turbine manufacturer. That's quite impressive. But Western wind manufacturers, they are not welcome to China. So you're not allowed into China if you are one of these companies. But these companies, they recruit actively from the West. And I know this because I worked for one of these companies, and my colleagues were constantly being recruited. So yeah, it's a kind of wind energy specialist war going on between these companies. So how is it looking for the cost of offshore wind? So for onshore wind, we see the numbers coming down. We see the trend. Onshore wind is reducing its installed cost per watt, and the number of gigawatts deployed is coming up. These are logarithmic scales. And this is kind of the trend we want to see. So you get into mass production, you are standardizing, you can reduce the cost, and we see how solar panels now are just dropping with a high gradient. Onshore wind, not as good as solar, but almost very close. And both onshore wind and solar is now like cost competitive to oil and gas. Offshore wind, however, is I don't know. We have some data points that it indicates it's coming down, but not enough by far, especially not for the modern economy. So high interest or high payback is key to make the modern economy invest in you. So this is not happening for offshore wind yet. Recently, Siemens Energy bought Siemens Gamesa, and then going through the company and checking that everything was in good shape, they found that it wasn't, and that brought down the stock for Siemens Energy by 30%. And that's quite impressive because Siemens Gamesa is a big company, but Siemens Energy is an enormous company. So to bring down the stock by 30%, and you have some issues. And especially the generators for the Siemens Gamesa turbines have been, they believe that 30% of all offshore generators from Siemens Gamesa needs to be changed due to errors in production. And this is offshore, so this has an enormous cost. And also the Ørsted stock went down nearly 50% some time ago when they pulled out from some American offshore wind projects. I was told that Ørsted joined this project early, and then inflation just happened, and at the end of the bidding process or making the contract, companies like Equinor came in much later and got much better deals. So Ørsted just had to pull out because it was not favorable for them. And it was a good time to buy shares in Ørsted, and all my friends that works in Ørsted, they did just that. I think Ørsted is a very good company that we will benefit from in the future. So this is the current state of the art when it comes to offshore wind. If you want to build an offshore wind farm, you should pick one of these turbines, according to the industry. And they are between 14 and 16 megawatt in power, and diameters of the rotor blades in the 236 to 280 meter range. So these are enormous machines. We see the Eiffel Tower in the background here, and a Boeing 747. So these are huge machines. Even so, Chinese companies have already started, like on concept level at least, 18 and 22 megawatts. So this race to have the biggest turbine is continuing, and it's also driven by the Chinese. So why is it important to have the biggest turbine? And the increase in swept area, of course, scales quadratic, makes the energy production scale quadratically. So if you increase the rotor diameter, the only term in the power equation that we actually can impact the swept area of the rotor blade is increased quadratically. So we see that we cannot do much about the density, the wind speed, even though it's to the power 3. It is it is what it is. And the power or efficiency of the rotor blade, wind turbine is pretty good. So it's not much to gain here. But it's super easy to make more power just by increasing the size of the wind turbine. So this is just continuing. And when you consider for these people that are building offshore wind farms, that a very small increase in the turbine capacity will have a huge impact on the economy of the wind farm over its 20-year lifespan. You are like mitigating risk. You are reducing risk if you are choosing the biggest turbine. So of course they do. That's easy. But these big turbines maybe are not as good as they hope. I consider them prototypes. We have some experience now operating 8 megawatt turbines for a couple of years, but we have almost zero experience operating these 14 to 16 megawatt turbines. So I don't think the economy linked to using these turbines is the best. And this is what we see in the stocks of the companies and wind energy going up and down. So the current size competition that the wind industry is in on is not looking too healthy for the economy. So what happens when we scale up the turbines? Well, the biggest change is, of course, the rotor blades get bigger, and with bigger rotor blades, we get higher Reynolds numbers due to the larger chord. And now we are in, these are like academic test turbines, 5, 10, and 15 megawatt turbines. So what we see with the 10 to 15 megawatt turbines is a Reynolds number in the 12 to 16 million number range. And this is kind of new territory for predicting the aerodynamic forces on the rotor blade accurately, because we don't have wind tunnels that can actually give us experimental data. So we cannot really validate the numerical models. Yeah. Another thing we are a bit concerned about going up in size like this is the local supersonic flow developing at like specific portions of the blade that might introduce vibrations that we don't have without supersonic flow. So that's another problem that size might introduce. And DTU has tried to like help the industry, and I also see, of course, a business idea in helping them. Siemens Gamesa paid DTU a lot of money to do airfoil testing. So everything that is going into the BEM tools of a wind turbine manufacturer in the end should be experimental tested airfoil data. And it's pretty difficult because it's so few wind tunnels that can do these high Reynolds numbers. So it's very few to pick from. And luckily, DTU has built a new one called the Paul tunnel, which is a close return tunnel, especially designed for aerodynamic and aeroacoustic testing of airfoils for wind turbine rotor blades. But when they started building this wind tunnel many years ago, I think they was hoping that the wind turbine rotor blades would not increase in size as much as they actually have. So even DTU didn't get this right. There are structural challenges with increasing the rotor blades. So here we have a rotor blade with like the buildup. You can see through it. So we have the gel coat on top, different layers of protection to protect the fibers. And then we have a shell, and this shell, up to now, at least as I know, and on the rotor blades that I have worked on, they are still in fiberglass. But we are using carbon fiber for the spar, for the stiffness in bending. But if we increase the size of the rotor blades further now, there is a big chance that we need to also do the shell in carbon fiber to keep the blade stiffness and tower clearance, of course. And this is a big jump in cost. Carbon fiber is very much more expensive than glass fiber. And also the availability of high quality carbon fiber is a bit sparse because the aerospace industry is using it. So that will drive cost again. But yeah, you see also the size of this thing now. It's the molds and the factories around them are just mind-blowingly big. So the fatigue testing for big blades, at least the ones for Siemens Gamesa, were performed like half outdoors, because the blades are just growing out of the factories. And by always having a bigger and bigger blade, I mean, it's very hard to standardize and automate the production. So these skilled labor, the skilled personnel that are actually hand putting the fiberglass and everything into the molds here by hand and performing the infusion molding, they are really needed. There's very few CNC machines in play still. For the bottom fixed turbines, we need installation vessels, and very few of them exist. They are very expensive, and they are also built to scale. So when you order one, you kind of tell them what size wind turbine you want to mount, and then that's what is being built. There has not been no tradition for building them too big, just in chance that there will be a bigger turbine. So when I say there is not many of them around, I don't know the exact number, but I looked around and numbers like 37, 20, 40 of these maybe exist in the world. So this might be a big bottleneck for the bottom fixed offshore wind industry if we have to put up a new turbine every day to make the 2050 goals. We don't have the boats to do it. So floating wind might do this much better, since we can actually install them in the docks, like we did with Hywind Tampen. But maybe Norway is one of few countries where the docks actually are deep enough for this operation. So for spa floaters like Hywind, you need a really deep fjord to actually mount the turbines. And then when we build the wind farms, there is like wakes coming off the individual turbines, and we position the turbines in the farm, so we optimize or minimize the wake effects. But there is also wake effects coming from the whole wind farm. And the distance between the wind farms will get important, because even though the ocean is big, there is a finite area to build wind farms on, actually. So if we clamp these wind farms together and we use two big wind turbines, big wind turbines produce much bigger wakes. Then we can run into the situation where we have this, we can call it wind theft, that the neighboring wind farm is actually stealing all the energy in the wind, and your wind farm that costs as much as the neighbors does not produce the same amount of money. So the optimal distance between the wind farms due to wake effects linked to the size of the turbine is a study that I think is really important to get the turbine size correct. In this work, the Bergen Offshore Wind Center has actually contributed already with a article where also the perspective of law comes in, which is called "Gone with the Wind: Wind Farm Induced Wakes and Regulatory Gaps." So it's linked below here. Quite nice work. Yes, this is Henrik Stiesdal. He is the inventor of the modern wind turbine as we know it today. He's the inventor of the Danish wind turbine. So this guy has been around since the start of the modern wind industry. He's been involved in Vestas, and he was chief engineer in Siemens Gamesa for many years. He is a guy you should listen to, and I actually found an interview with him where he has something to say about the turbine size as well. So he is really wanting EU to set a limit on turbine height to stop this race that is going on towards bigger and bigger turbines. Because it is quite evident that the modern economy and the wind industry is not able to stop this spiral by itself. Yes, so he is proposing maximum height of around 300 meters, which maybe will put the turbines that we have today, then that will be it. We will aim for a turbine of this size. And then we can start to refine them, optimize them, make them more robust, make them less costly, is his ambition. It should be all of our ambitions. And I think this idea has this potential to save many years, because if the wind industry has what they really want to converge to the correct turbine size just by trying and testing it out. But I'm not sure if we can wait for that if we want to accomplish the Green Deal. So I think this is valuable input to accelerate the green shift and help EU accomplish this Green Deal. And the whole interview is linked below here. And there's some information about Henrik. Yes, I'm not sure if that was too quick, but we can have a good talk about questions maybe.
Thank you very much. I think this was a very good time. I will switch off the recording. So then the floor is open for people to just ask questions, and